In this video, we'll answer the most frequently asked UltraShear related questions.
What is fluid shear?
Shear is the disruptive force necessary to deform or rupture an object. To get shear, you need to push one side of that object to the right while pushing the other side to the left. In a fluid homogenizer, shear is produced by pushing a fluid through a gap. Objects suspended in the flow are subjected to shear as different layers of the flow are moving at different velocities. The higher the flow velocity, and the smaller the gap, the greater is the shear rate and thus shear stress available to overcome a cohesive force like surface tension. Once the cohesive force is overwhelmed, objects like oil droplets in water are ruptured into smaller droplets. This goes on until the shear and surface tension forces come back into balance.
How is UltraShear different than homogenization?
UltraShear is homogenization but at extreme conditions. To get higher shear, we increase the pressure driving fluid flow. A typical milk homogenizer is a pump that works at 2000 psi. In UltraShear, we increase velocity many times over conventional homogenizers by using pressure above 40,000 psi. As a result, our velocity can be 20 times greater. To decrease the gap distance, high-pressure homogenizers typically use a fixed opening in the form of an orifice or microchannel. They need to make this as small as they can, but without subjecting the whole system to clogging. Very small, fixed openings will easily clog if made too small. In UltraShear, we decrease gap distance by over an order of magnitude by using a self-throttling valve. Self-throttling avoids clogging as it can self-relieve if a clog starts. The UltraShear nanogap valve can work at a gap distance an order of magnitude smaller than fixed openings, thus greatly elevating shear rate.
Why is such high shear rate needed?
High shear is a physical method to disrupt distinct phases within a fluid without the use of strong chemicals. For example, oil in water is an immiscible liquid in liquid, multi-phase mixture. Large oil droplets quickly float to the top causing separation. If the oil droplets are broken into extremely small droplets, to a size where density forces are less than the thermal vibration force, density no longer matters, separation cannot take place and a stable colloidal suspension with properties mimicking a miscible solution becomes possible. In addition, extremely small droplets have high mobility, and their biological or chemical activity can be greatly enhanced. When the droplets are in the under 200 nanometers range, these are frequently called nanoemulsions. To achieve this size range, intense shear rates are needed. Worldwide science shows many benefits of nanoemulsions for nutritional, pharmaceutical, food, cosmetics, and other products. In fact, there are other noteworthy potentials for UltraShear. UltraShear can be applied to inactivate microorganisms. For example, it is well known that yeast cells can be physically destroyed by shear. UltraShear can be applied to weakly bonded or agglomerated solid in liquid mixtures to refine particle size. And combining high hydrostatic pressure, temperature control and shear can be applied to alter product characteristics such as viscosity and flavor.
Is UltraShear equipment just a beefed-up homogenizer?
Not really. We already covered the difference between a fixed opening shear valve and the UltraShear valve. In regards to how the product gets its pressure, in a conventional homogenizer, fluid enters a plunger pump and is pushed out of a small opening. While this is a practical approach for many products that only need a few thousand psi of pressure, following this concept to ultra-high pressure such as 45,000 psi becomes impractical as the stresses and forces become enormous. For example, to move a 2-inch diameter homogenizer plunger at 45 ksi, you will need over 141,000 pounds of force. That is the weight of over 71-ton cows. That would be one difficult and expensive pump manufacturing challenge. The UltraShear process uses a baroisolator to transfer pressure from a highly efficient high-pressure pump to the product. The product never enters the pump but rather enters an intermediate isolation bladder only in pressure communication with the pump. This greatly reduces the size and cost of the equipment. This improves the cleanability of the system as the source of the high pressure is no longer in physical contact with the product. UltraShear-capable pumps operate at high RPM and are engineered with the state-of-the-art materials to give long reliable operation at lower cost than complex high-pressure homogenizer intensifiers driven by messy hydraulic oil. In conclusion, UltraShear can achieve higher shear rate for greater disruption, and UltraShear can operate more economically and reliably than fixed opening valves. Let's work together to explore the possibilities. Thank you.